Hello everyone. In this video, we are going to discuss about Newton's second law of motion and the mathematical formulation of Newton's second law of motion. So first let us discuss Newton's second law of motion, its statement and some examples, and after that we will discuss the mathematical formulation of Newton's second law of motion. In the previous video, we have discussed about Newton's first law of motion and we said that the object remains at state of rest or of uniform motion unless an external unbalanced force acts on it. But what happens when an external unbalanced force acts on an object? Its state changes, no? That is, the object at rest may move, the object in motion may come to rest. Right, that is, when an external unbalanced force acts on an object, its velocity changes. We know that when there is a change in velocity, there is an acceleration. That is, you just consider this pencil. Okay, consider this pencil. Then this pencil, it is a state of rest now. Now, when we apply some external force on it, what happens? The pencil moves. So initially, it was at state of rest. That is, its velocity was 0. When we apply some external force on it, it moves. That means it has some particular velocity at that particular time during its motion. Right. So there is a change in velocity and the object gets an acceleration. We would like to know how the acceleration of an object depends on the force applied to it. So let us recall some observations from our everyday life. So here we know that during the game of table tennis, if the ball hits, you just consider this as the table tennis ball, if the ball hits a player, it does not hurt him. But when a fast moving cricket ball hits a person, it may hurt him. Here you want to notice one thing, a table tennis ball has less mass than a cricket ball. And we considered a fast moving cricket ball, so its velocity is greater than the velocity of the table tennis ball. Okay, that is, the impact produced by the object depends on its mass and velocity. That is, the impact produced by the objects depends on their mass and velocity. Now you just consider a truck which is at rest, that is, a truck is parked somewhere and someone hit that parked truck while walking. That may not hurt him much. But when the same truck is moving with some velocity and hit a person who is walking on the road, what happens? The moving truck may kill that person. Right. So here we consider the same truck, so masses are the same, but the velocity is different, no? One was a parked truck, so its velocity is equal to 0, no? Another case was of moving truck, so that had some velocity. That is, the impact produced by the objects depends on their velocity. Now, a bullet which is a very small mass may kill a person when fired from a gun. All these examples suggest that the impact produced by the objects depends on their mass and velocity. Similarly, if an object is to be accelerated, a greater force is required to give a greater velocity. There exists a quantity of importance that combines object's mass and velocity, that is momentum. The concept of momentum was introduced by Newton. So momentum, it is actually represented by the letter P. The concept of momentum is actually introduced by Sir Isaac Newton. Momentum of an object is defined as the product of the mass of the object and the velocity of the object. So momentum is represented by the letter P. It is defined as the product of mass of the object and velocity of the object. So we can write momentum P is equal to mass into velocity. Okay, now momentum, it is a vector quantity. It is the amount of motion possessed by an object. It is a quantity of motion of a moving body. Momentum has both direction and magnitude because it is a vector quantity. The direction of momentum is same as that of velocity. Now, what will be the SI unit of momentum? if to get the SI unit of momentum, we just want to write the SI unit of mass, that is kilogram, then into SI unit of velocity, that is meter second raised to minus 1 or meter per second. So kilogram meter second raised to minus 1 or kilogram meter per second is the SI unit of momentum. We know that when an unbalanced external force acts on an object, its velocity changes. When there is a change in velocity, there is a change in momentum. Right, when there is a change, because momentum is the product of mass and velocity. So when there is a change in velocity, there is a change in momentum. Alright, therefore it is clear that the force brings a change in the velocity of the object and the force also produces a change of momentum. Because when there is a change in velocity, there is a change in momentum. Right, now consider a situation in which a car with a dead battery is to be pushed along a straight road to give it to a speed of 1 meter second raised to minus 1, which is sufficient to start the engine. If one or two persons give a sudden push or an unbalanced force to this car, it hardly starts. But a continuous push over some time results in a gradual acceleration of the car to this speed of 1 meter second raised to minus 1. You might have noticed this. So, there is a change in velocity of the car, hence there is a change in momentum. Okay, when there is a change in velocity, there is a change in momentum. So, there is a change in the velocity of the car, so there is a change in its momentum. The change of momentum of the car is not only determined by the magnitude of the force, but also by the time during which the force is exerted. Alright, the change of momentum of the car is not only determined by the magnitude of the force, but also by the time during which the force is exerted. Because we said when one or two persons give a sudden push or an unbalanced force to the car, it hardly starts. But a continuous push over some time. So there is an important for that duration of time. Okay, then that results in a gradual acceleration of the car. Then the car may start easily. So there is a change in velocity of the car, hence there is a change in its momentum. The change of momentum of this car is not only determined by the magnitude of the force exerted by these persons on the car, but also by the time during which the force is exerted. Okay. Now, let us talk about the statement of Newton's second law of motion. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So the rate of change of momentum of an object is proportional to the applied unbalanced force. When the applied unbalanced force increases, the rate of change of momentum also increases. So when it decreases, the other one also decreases. Okay, so rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That is a statement of Newton's second law of motion. Now, let us talk about the mathematical formulation of second law of motion. Consider an object which has a mass small letter m moving along a straight line. Okay, you just want to consider an object of mass m moving along a straight line. Let its initial velocity be u. When we apply a constant force F on this object throughout the time t, okay, then its velocity changes, that is its velocity changes to another value v in time t. Okay, that is, here we have considered one object of mass m moving along a straight line. Its initial velocity is u, that is initially it was moving with the velocity u. But when we apply some external force F on this object, obviously its velocity changes to another value. That value is v. This force is actually applied on this object throughout the time t. So its velocity changes to another value in time t. Okay, so there is a change in velocity from u to v. That means there is an acceleration. Right. Now, mass of the object is m. Its initial velocity is u. So what about its initial momentum? We have the expression for the momentum as momentum p is equal to mass into velocity. So if m is the mass of the object and u is the initial velocity, so what about its initial momentum? I am taking it as p1. Okay, initial momentum p1 is equal to mass of the object into initial velocity, which is u. Okay, now again mass of the object is m. Its final velocity is v. Okay, so what about its final momentum? I'm taking its final momentum as P2. So we can write P2 as momentum is equal to, it is a product of mass and velocity. So P2 is equal to mass of the object m. There is no change in mass. Okay, so mass of the object m into the final velocity. Final velocity is v. So we got the initial momentum P1 and we got the final momentum P2. Alright, now what about the change in momentum? Change in momentum, that will be equal to what? Final momentum minus initial momentum. Change in momentum is equal to final momentum minus initial momentum. What is final momentum? P2 minus initial momentum P1. Okay, so we can write the change in momentum as what is P2 m into v minus what is P1 m into u. Alright, so we can write the change in momentum as, we can take this m as common, so this can be written as m into v minus u. Okay, so we got the change in momentum as m into v minus u. So we got the change in momentum as m into v minus u. So what about the rate of change of momentum? Rate of change of momentum means what? M into v minus u divided by time. Okay, time t. Okay, that time during which the force is applied on this object. So change in momentum is m into v minus u. So rate of change of momentum is m into v minus u divided by t. Alright. So we got the rate of change of momentum as m into v minus u divided by t. Now, as per Newton's second law of motion, this rate of change of momentum is proportional to the applied unbalanced force, no? Okay, according to Newton's second law of motion, this rate of change of momentum is proportional to the applied unbalanced force. So, let that applied unbalanced, what is that applied unbalanced force on that object? We have applied a force F, no? So, F is proportional to what? That rate of change of momentum. That is m into v minus u divided by t. Okay, so according to Newton's second law of motion, this rate of change of momentum is proportional to the applied unbalanced force. So here the applied unbalanced force is F. So we can write F is proportional to m into v minus u divided by t. Okay, now here we have a proportionality sign. While we are replacing this proportionality sign with an equal sign, we have to write one proportionality constant over here. Okay, so we are writing that proportionality constant. We are taking that proportionality constant as k. So we can write F is equal to some k into m into v minus u divided by t. Okay, here we have actually a proportionality relation, and while we are writing this proportionality relation in terms of an equation, that is while we are replacing this proportionality sign with an equal sign, we will write one proportionality constant here. So here we are taking that proportionality constant as k. Okay, so we can write F is equal to some k into m into v minus u divided by t. Okay, now what is this v minus u divided by t? Final velocity minus initial velocity divided by time. That is change in velocity divided by time. This is the rate of change of velocity. What is rate of change of velocity? Acceleration. Right. So we can write F as k into, which is a proportionality constant, k into m into a. Alright. Now, I'm taking this k as 1. Okay, I'm taking the value of k as 1. So we can write this force as F is equal to m into a, which is actually a mathematical expression of this Newton's second law of motion. F is equal to m into a. Alright, now what will be the SI unit of force? So we got one expression for the force in terms of acceleration and mass of that object. Okay, so we got F is equal to m into a, which is the mathematical equation which is corresponding to that Newton's second law of motion. F is equal to m into a. Alright, so F is equal to m into a. What will be the SI unit of force? To get the SI unit of force, we want to write the SI unit of mass, which is kilogram, and we want to write the SI unit of acceleration, which is meter per second square. So kilogram meter per second square or kilogram meter second raised to minus 2. If I am taking the second square to the numerator, it becomes second raised to minus 2. Right, so kilogram meter per second square or kilogram meter second raised to minus 2 is the SI unit of force. We usually take the SI unit of force as Newton, which is named after Sir Isaac Newton. So we can write 1 Newton as 1 kilogram meter second raised to minus 2. Okay, SI unit of force is Newton, taken as Newton. Then that will be equal to what? SI unit of mass, kilogram, into SI unit of acceleration, meter second raised to minus 2 or meter per second square. So we can write 1 Newton is equal to 1 kilogram meter second raised to minus 2. So we can define 1 Newton as the amount of force required to produce an acceleration of 1 meter second raised to minus 2 in an object of 1 kilogram mass. Okay, that is, for example, we have an object here which has a mass of 1 kilogram. Then to produce an acceleration of 1 meter second raised to minus 2, we have to apply 1 Newton force on this object. Okay, so 1 Newton can be defined as the amount of force required to produce an acceleration of 1 meter second raised to minus 2 in an object of 1 kilogram mass. Okay, so the second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. Okay, second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. So, in this video, we have discussed about Newton's second law of motion and its mathematical formulation of second law of motion. The second law of motion is often seen in action in our everyday life. We will discuss about that in our next video. Anyway, I will provide the link in the description box. If you want, you can watch that. I hope you understood the statement of Newton's second law of motion. I hope you understood the concept of momentum, the equation, the units, and the mathematical formulation of Newton's second law of motion. Thank you.